Longboard sliding is the act of breaking the traction between your wheels and the road while longboarding by shifting your weight close to the ground, creating a pivot point with sliding gloves on the side of the board touching the asphalt, and pushing a foot along the grip of the board, like this.
Just do it!
Like this. If the traction between the grip of the board is less than the board's grip on the road, when attempting to slide, the only thing sliding will be you off of the board. You can only keep traction between the wheels and the asphalt by approaching a sufficient velocity to keep the board moving at the same velocity while it pivots on the road. Turning the board sideways is similar to hitting your brakes hard while driving at high speeds. This means that the greater kinetic energy that a longboard has before a slide, the longer it can slide and the easier it will be to break traction. My goal was to find out how much energy it takes to break the traction in a slide. I guessed that that number varies based on your initial velocity. My average initial velocity equaled 4 meters per second, or roughly 9 miles per hour. I used a physics video editing program to plot the different positions of the wheels for every frame of a longboard slide. I found that when sliding in a 180 to change the board direction, one wheel is usually the pivot wheel, while the rest move around it in comparison, as shown here. Since the board ends up in a position exactly parallel to what it was before, the net friction of the wheels is equal to the coefficient of static friction at about 90 degrees. To find the coefficient of static friction between the wheels of my board and the road, I first found the spring constant of a small tension spring using a few weights in this contraption. Next, I went outside to test the board by attaching the spring to it at a 90-degree angle along its middle and measuring the distance the spring stretched before the system moved. Finally, I found mu by multiplying the spring constant by the delta x of the spring and dividing it all by the weight of the board. I found that the mu of the board equals 0.804, compared to the coefficient of friction of a car tire, which is about 0.7. My average slide was about 1 meter. I used the skid runway equation, Vf squared equals Vi plus 2a delta x, and the work equation, where work equals force times d cosine theta, where d is equal to delta x, to calculate how many newtons of force went into my average slide. I don't think it worked very well. Cheese, an addicted cruiser from New Zealand, says that, due to all the factors in longboarding, it becomes impossible to calculate the force. For example, how much you weight your board, as in how far your hand is away, pavement in comparison to your wheels and pucks, weight placement during the slide, pendy, 180, pre-drift, speed check, they all have different weight placement. Basically, to really calculate accurately how much energy it takes to make a longboard slide, you must know a lot more about your slide than I do. The angle of pivot and where your weight is positioned on the board, and even the angle at which each foot comes into contact with the board needs to be known. Next time, maybe I can get someone else to find all this stuff out for me. But hey, thanks for watching.